Hello out there. Welcome to another Beast Mode production. I like the voice Beast Mode production on scientific notation. And so that's what this lesson is on. And I will say this. Remember, you are not watching this video just to write down what I write down. Only you are watching the video to understand. For instance, just hypothetically speaking, if I had a student by the name of Sydney, and this student by the name of Sydney did not understand what I was doing in the video, that student would send me a remind or an email to say, hey, Mr. O'Neill, just hypothetically speaking, I did not get the video or I didn't understand this concept. So please answer my question. And being the great teacher that I am, I would do that. All right, just hypothetically speaking. Now let's get into the real world. Scientific notation, easy concept, many different pieces, but if you get it all together, you'll be fine. So scientific notation is a special way of writing very large or very small numbers. Scientific notation is a special way of writing very large or very small numbers. If you need to write that down, you can. You're supposed to. Whatever I don't finish in the video, you will do for homework. The first number is called the multiplier. So you're making ease on this thing. It's I don't understand. Just loop around. It's called a multiplier. The first number in front of the multiplication symbol and 10 to the certain power. So it's written as the first number as a decimal. This number is going to be the number in front, which is the multiplier, is going to be greater than 1, but is going to be the number is going to be less than 10. Okay? The number is going to be greater than 1, but less than 10. All right? This is the multiplier. It is a decimal. So even if the number, there we go with these e's again, even if the number was 3, we'll write 3.0. Okay? So it's a decimal. If the number was 5, we'll write 5.0. We write it as a decimal. This number right here is the power, exponent or power. I'm trying to make an arrow. Power, come on, 0. There we go. I'm just gonna write in cursive. All right. The power is going to be positive or, come on, or negative. Okay. It can be positive or negative. All right. So understanding these rules, it says determine whether each of the following numbers are written in scientific notation. If they are not, rewrite them so they are written in scientific notation. We're going to come back and do that. We're not going to do that right now. So is this number in scientific notation? Let's look at the multiplier. The multiplier, this is 3.12. Is it greater than 1? Yes. But less than 10? Yes. Is it times, because it's more times, 10 to a power that's positive or negative? Yes. So is this in scientific notation? Yes, it is. We need to rewrite this? No. Look at that E. I put it in cursive. Yes. Is this a scientific notation? This number is greater than 10. No. We're going to come back and write it in scientific notation once we practice writing. Is this number, is the multiplier, I shouldn't say the number, it has a name. Is the multiplier greater than 1 but less than 10? It is less than 1. This is not in scientific notation. No. Okay? So for homework, you're going to say yes or no. And then we're going to come back and write these in scientific notation, so leave some room. So that's your homework. 2, 4, and 6 is on you. All right. Make sure I do this right. Okay, turn the page. Positive powers. Positive powers are with numbers that are greater than 1. When I teach scientific notation, we move from left to right too often for me to say if you go right, it's positive. If you go left, it's negative. No, I do not. I do not. I do not. I, Mr. O'Neill, do not teach you if you go a certain direction, it's positive. I teach you if the number that you're looking at is greater than 1, it's going to have a positive power. So in order to write this in scientific notation, the multiplier needs to be greater than 1, but less than 10. So I'm going to take 75 million and I'm going to write it in scientific notation. So the decimal has to go in a way in between the numbers so that the multiplier is going to be greater than 1, sorry, but less than 10. The only way for that to happen is for me to put the decimal here. Man, put the decimal here. I want a decimal. All right, just that little dot right there, it's the decimal. Okay, you can do better. I know you can. I believe in you. And so that's the only way that I can make the 75 million into scientific notation. If I put the decimal here, if I put it here, the number would be greater than 10. If I put it here, the number would be less than 1. It wouldn't qualify. So how do I write this? Well, I say, okay, so if the decimal is here, so I say our multiplier is going to be 7.5, a little point, and then times 10. And so how many powers? Well, every time I move, that's a power. Because how do we increase this number? If I multiply by 10, I am increasing the number by every time I move. Okay, so I'm going to move all the way to the end. So I move 1, 2, 3, 4, 5, 6, 7. So 7.5 times 10 to the 7th power. That's what this is. And how do I know this is a positive power? Because the number is greater than 1. It is not because we move to the right. Lies. It is because the number is greater than 1. All right, so how can I set up this multiplier? Well, if I put it here, it's going to be less than 1. If I put it here, the multiplier will be greater than 1, but less than 10. So I want the decimal to be there. Y'all know about my little decimal. Oh, I forgot to say we drop all zeros because if I put a 0 here, it's still 7.5. So if 0 is not between two numbers, we drop them. Hint, 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 hint. If the 0 is not between two numbers that are not 0, we drop them. Hint, 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 hint. All right, so my multiplier then would be 8.19. And then where do I move this? I move this 1, 2, 3, 4, 5, 6. So times 10 to the 6th power. Okay, so this number in standard form, this is standard form. Write that down. This is standard. You gotta write in cursive because you know. Standard form. This stuff want to come all out super late. Standard form, and then we turn this into scientific notation. Okay, this is standard form. Somebody in math just love the word standard form because you'll hear it over and over again. I don't understand. They were not creative. All right, so homework. Homework. Yay. So it says rewrite each number in standard notation or standard form, standard notation, standard form. So this is 7.8 times 10 to the 9th power. Oh, what does this 9 mean? That means I started off with a number greater than 1. Don't do that. Stop it. I'm doing the wrong thing. Stop it. So I tell you, stuff don't want to act right. Let's do this. That's what I was doing. Really? Where did you go? I'm pausing the video. I'll be back, y'all. All right, people, I made it back. Some haters out here. But rewriting standard notation or standard form. Okay, so this number means that it's a positive exponent. So positive exponents grow. Okay, positive exponents, positive. Here we go in cursive, I forgot. Positive exponents. Sorry about this handwriting, y'all. Grow. All right. So where do we grow? Now, I can talk about left or right here because you should know that the numbers grow to the right. So in scientific notation, that means that there were 9 times, 9 loop-de-loops, call them loop-de-loops, that I make. I think Preston would like that. Who else would like that? Alex might find a little joy when I say loop-de-loops. Amon find joy in everything. He would like that. Okay. Loop-de-loops, probably Cameron. Okay, let me stop. I'm talking too much. All right, so 9 loop-de-loops was made to get this number to be 7.8. So what would I have to do? I have to loop-de-loop again, back out to figure out what the original number was. So I loop-de-loop 9 times. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 0. Hopefully this turns out right. Y'all know these zeros and stuff don't want to turn out right. Okay. And so this is now 7, 8. I'm going to rewrite the number. 1, 2, 3, 3, 4. Oh gosh. Don't do this! I'll be back, y'all. I just don't understand. I'm having technical difficulties. Oh yeah, I can hit this button. It should go back. I don't understand why life doesn't like me today. I don't get it. But It was 7, 8. Look at this 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8 zeros. Y'all get the point. I can't, I'm not remaking this. I'm done. I've been having stuff all day. So if you don't learn it and it's my fault, then go watch Khan Academy after you watch my video because my videos are better. All right, so and they're more entertaining. Okay, so 3.91 times 10 to the fifth power. That means the number grew, and so it grew. This number is going to grow by 5 loop-de-loops. So I start off with 3.91, and I'm going to loop-de-loop 5 times. 1, 2, 3, 4, 5. That's a 0. I'm not going to rewrite this for the sake of embarrassing myself. I think if I make a 0 like that, they'll turn. Okay, so 3, 9, 1, 0, 0, 0. Is that what it is? 3 zeros. All right. So the number is 391,000. Okay. So you're going to have better success than me. You're going to do 6 and 8 for homework. And then there is an EC. That's an extra credit. I don't know how I'm going to do this. Maybe I'm going to send it to Remind. There is a, no, let me just ask it when you get over here. All right. So let's move to the next one. All right. Negative powers are with numbers that are less than 1. Look at here. The reason why, nope, wrong software. The reason why I know I'm going to use a negative exponent or negative power because these numbers are less than 1. All right? So rewrite each number in scientific notation. This is standard notation or standard form, however you want to say it. Standard notation. We should probably say standard notation since we use standard form. Standard notation. And so we want the decimal, again, to be in between a number so that the number will be greater than 1, but less than 10. The only way for that to happen, everybody, is so the decimal will be right there. Okay? So we loop the loop. So notice it just depends on where you loop the loop. Some people loop the loop back to the decimal. Some people loop the loop this way. I don't go left or right. I know it's going to be negative because this number is less than 1. All right. So we loop the loop. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. Okay, so scientific notation 5.8 times 10 special to the negative fifth power. That's what that is, y'all. That's not an and sign. 5.8 times 10 to the negative fifth power. Why? Because this number is less than 10. Where do I want this decimal at? Between the two numbers, it's going to make this, you get the point. All right, so we loop de loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I should have 3.7 times 10 to the negative 10th power. Look at that. Look at this. It's beautiful. And well, guess what you're doing? 2 and 4. All right, moving on, moving on, moving on, moving on, moving on. Rewrite each number in standard notation. Okay, so standard notation means that I loop the loop 7 times, but negative exponents, negative, savior, sorry, exponents make numbers, okay, that's what would be numbers, shrink. Okay, duh, they get smaller. That's what a negative exponent means. So where the number gets smaller? To the left, duh. So this is 6.13. So if I know I'm going to the left, I'm going to bring this number out to the right because I have to shrink 7 times to the left. It's supposed to be a 3. Y'all forgive me. I'm just having some struggles. Oh gosh, here we go. Don't do it. All right. So 1, 2, 3, 4, 5, 6, 7. Boy, these some ugly loop-de-loops. 1, 2, 3. Make it. You stop it. Just obey me. Oh, there we go. 4, 5, 6, 6. And then, and that was that. So we have point. I don't know what to do, y'all. 1, 2, 2. You get it. That's what it is. Just rewrite it over, y'all. Just rewrite it. I'm sorry, just rewrite it. Just rewrite it. All right, so this means that the number shrunk 3 times. Yay! So we start over here and we have 5.5. You know how you stay positive even when stuff is going down? It's a life lesson. You just gotta make the best. When life hands you lemons, make a lemon tart or something that you really like, or a lemon cheesecake. That's what I'm doing. I'm making a lemon cheesecake. I'm not making lemon juice or lemonade. It would be lemon juice. All right, anyway, 0.0055. Okay, so there is an extra credit assignment. If you can figure out how to know how many zeros you will have without doing loop de loop, you'll share this with me somehow tomorrow, and you'll get some extra credit. So I don't have to loop de loop to find out how many zeros I'm going to have. By just looking at the exponent, looking at my number, I can figure out how many zeros I'm going to have. So you'd be able to tell me that, then your life would be a lot easier, and you don't have to loop de loop every time. If not, then you can loop de loop forever. All right, let's move on. So multiplying or dividing in a scientific notation. I lost my train of thought. So when you're multiplying and dividing scientific notation, use the exponent rules for the powers of 10. Make sure the final answer is in scientific notation. So multiply or divide the multipliers. That's what you do first. Multiply or divide the multipliers. I got my little handy dandy calculator right here. And so this is going to be with your calculator. You can do all this in your calculator and even put it in scientific notation. I'm not going to do that though, because I'm okay, so multiply the multiplier. So 3.2 times 1.75. Multiply them. 3.2 times 1.75. Who's looked at it distributing in a way? So 3.2 times 1.75 gives you 5.6. So 5.6. And then 10 to the fifth times 10 to the third is going to give you, multiply exponents. Put your hands up. What do you do? Multiply exponents, keep the base and add the exponents. I can see Jordan doing that now. Go ahead, Jordan. Him and Nick, his brother, Latrell. So 5 plus 3 is 8. All right, what do we do here? 1.58 divided by 2.5 because it says multiply or divide the multipliers. That gives me, oh gosh, we got to go back. Point, shoot, this video is going to be long. I'm sorry. 0.632. 0.632, and then when we divide, keep the base and subtract the exponents, times 10 to the 6 minus 3 is 3. And in scientific notation, we can have negative exponents. So if you do end up with a negative exponent, that is fine. The problem is this is not in scientific notation. Let's have a conversation. So in order for this to be in scientific notation, let's see if we loop de loop. If we loop de loop this number, and we're going to learn this lesson, and you can go back and learn it, and I'm going to teach it as well. But if we loop de loop this number 3 times, the number is 632. That's what the number is in standard notation. You don't have to write this part down. In fact, you can just watch me make another ugly looking number. All right, 632. So if I move this here, that's what I want to do, and make this the multiplier of 6.32. How do you get a 2 out of this thing? A 2. There we go. What did I do with the exponent? Well, I made the number larger. And so to keep the number the same, since I made it larger by moving it over, since I multiplied by 10 to make it larger, I must divide this by 10. And we know when we divide exponents, we subtract. So I have to subtract by 1. Because if I multiply by 10, that's basically saying divide this by 10, and I'm taking 1 away. So this is called give and take. If you have to give a multiplier a extra place value, then you need to take away from the power. Again, if you have to give the multiplier, give to the multiplier, you have to take away from the power. So this is going to be times 10, 10 to the second. Whatever. 10 to the second. Yep, that's what that is. All that is 10 to the second. Okay, and doesn't that make sense? Because it keeps the number the same. 632, if I move this over twice, is 632. If I gave to this, then I'll be saying 10 to the fourth, and then that means I'm moving this 4 times. 1, 2, 3, 4. I end up with 2 zeros right here, and so that's 63,200. That's not the same number. So if you have to give, you have to take. Now let's go. You're going to do the rest of these for homework. I apologize about this video. I guess I need to give everybody a white ticket for watching this video and with all these mistakes. And I'm sorry. I don't know what's going on with my software. But these are homework. That's what you're doing for homework. Don't forget, divide the multipliers, multiply the multipliers, divide the multipliers. And it has to be in scientific notation. I see some of y'all going to mess up on that. So let's go back to the beginning page. I'm going to be done in the next 2 to 3 minutes. I try to promise you. So remember when we came here and we said, hey, this is in scientific notation. Yay, this is not. No. And the reason why it's not in scientific notation is because, forget all of y'all. It's because this number is greater than what? Is greater than 1. So what do I have to do? I don't want to give because giving is going to make the number even more larger than 10. Sorry, the number is greater than 10, not greater than 1. The number is greater than 10. It's going to make the number even larger than 10. It's not going to fix the problem. So I need to take. And so if I take, I need to give to keep the number the same. 1. So the number is now 9.12 times 10 to the fourth power. Okay? That's what that number is in scientific notation. If I put this out, I will get the same number. So what about this one? This is not in scientific notation because it's less than 1. So I need to give to you. And if I give to you, I need to take from you to keep the number the same. So this is going to be 1.3 times 10 to the negative 6 power. All right? And so when you come over here now and do these, you'll now know what to do. All right, I'm done. I hope you have an amazing day, amazing life, and I hope your life is better. Yeah. This has been another Beast Mode production. I can't even feel like I can pull out my little signature move because these daggone hating machines. Look, it done deleted everything. You know, I'm proud of y'all for watching this video. That made me so proud to be your teacher. All right, there we go. We can get something out that may look like something that I would do. You don't have to watch the rest of this. It's just me struggling to do what I always do in a video. You don't have to watch this. You can turn it off. I'm just gonna just put my little check. Try to put my little check here. Oh, look at my check. And then try to write my name. Oh, come on, write my name. Mr. O'Neal. And then do my little signature move and say, we out.